Welcome to FluidFlow. We're confident you'll enjoy using FluidFlow and appreciate you taking the time to evaluate the software. This Get Started series of videos will introduce you to the basic concepts of piping system modeling within FluidFlow and have your modeling in no time at all. FluidFlow is a powerful tool that allows us to take all the components to make up a modern fluid transport system, including pipes, pumps, line equipment, and heat exchangers. Users can model them all together to gain a deep understanding of how the piping system will operate for different scenarios. We can investigate friction losses, flows, temperatures, and many other parameters throughout the model to deliver an optimized design. The engineer can be confident that the results are safe, reliable, efficient, and also traceable. There are some things we can do before we begin using the software that will lead to a cleaner model with the ability to effectively communicate our design to other stakeholders involved in the project. The first decision we can make is whether to build in an isometric mode or an orthogonal mode. Isometric modeling is a good choice when elevation plays an important role in the design, as shown in this model. In this sample model, we can see that the return line discharges into the top of the tank, while the pump suction is connected to the bottom of the tank. We can also see that the heat exchangers are located in an elevated area of the plant. Orthogonal mode can be used when elevation is not so important or when a top-down or section view is beneficial. An orthogonal mode can often be easier to understand visually. This fire hydrant system, for example, has been modeled to match the site layout drawing, which allows all project team members to instantly recognize it. The next step is to plan how the model will look on the flow sheet. Good planning at this stage can help you avoid the need for rework later on. For example, this model, although very simple, looks cluttered and confused. Selecting individual components or pipes is difficult, and the design intent of the system isn't clear. This version, however, is much clearer in that we can easily select the individual pipes in between the components, and we can see the logic of the directional components. The design intent is also communicated with clarity, and as the project progresses, troubleshooting and other design work will be handled efficiently. Our next video introduces you to the graphical user interface of using FluidFlow, and from then, we will get you started in building your first model.